During the 19th century, the Austrian monk Gregor Mendel performed specific crosses with pea plants and worked out much of what we know today about the laws of heredity. We will use his ideas to consider the inheritance of a single trait, freckles. The inheritance of freckles is determined by a dominant allele. Suppose a freckled female who was homozygous dominant, big F, mated with a homozygous recessive male with no freckles, little f. How likely is it that their child will have freckles? A Punnett square helps determine the probable outcome of the genetic cross. Both parents are homozygous, so each can produce only one type of gamete as far as freckles are concerned. The female produces gametes with the dominant allele, big F, and the male produces gametes with the recessive allele, little f. Each square in the resulting table is filled in by combining the alleles from the sperm and eggs. In this example, all the children would be heterozygous for the trait big F, little f, and therefore would have freckles. Now let's consider why it's possible for parents who are both heterozygous for the freckle trait to have a child without freckles. The dominant F and recessive F alleles segregate during meiosis, so half the gametes bear the dominant F allele and half bear the recessive F allele. Filling the boxes, we see that the probable genotypes of the children would be in a genotypic ratio of 1 homozygous dominant, big F, to 2 heterozygous, big F, little f, to 1 homozygous recessive, little f. Phenotypically, the children would be 3 freckled to 1 not freckled. A child from these parents would have a 25% chance of not having freckles. Suppose 2 people who are heterozygous for widow's peak and freckles mate. Freckles and a widow's peak are both controlled by dominant alleles, so these heterozygous individuals show both traits. Would it be possible for this couple to have a child that had neither freckles nor a widow's peak? We can use a Punnett square to analyze a 2-trait cross, as long as the genes for the 2 traits are on different chromosomes. Keep in mind that during gamete formation, the alleles for a gene segregate, and that genes for different traits that are located on different chromosomes will segregate independently of one another. Therefore, 4 possible allele combinations are produced in the gametes: dominant F, dominant W, dominant F, recessive W, recessive F, dominant W, and recessive F, recessive W. Each type of gamete has an equal chance of joining with any other type at fertilization. The relative numbers of phenotypes possible for the next generation are 9 freckled with widow's peak, to 3 freckled with straight hairline, to 3 no freckles with widow's peak, to 1 no freckles with straight hairline. The expected phenotypic ratio is 9 to 3 to 3 to 1.